Okay, the Introduction to Dynamic Programming in Economics. The textbook by Stokey, Lucas, and Prescott, Recursive Methods in Economic Dynamics, is a Bible in macroeconomics, and lots of postgraduate economics students study it. It is also often used as a textbook for first year PhD econ courses, and it's a very difficult textbook. Their chapter 2 is the overviews of dynamic programming method, but it's really hard to understand for at least some of us. So the intention of this lecture series is to give introduction to dynamic programming, and is designed for those students who tried to study their textbook but couldn't even get the very beginning ideas. So if you are okay with like chapters 2, 3, and 4 of their textbook, then you don't need this lecture. If you didn't feel comfortable with the beginning chapters of the textbook, if you are not even sure what makes you feel uncomfortable, then hopefully after this lecture, you will feel more comfortable about dynamic programming. The lecture is composed of 4 classes: backward induction, stepwise maximization, recursion, and dynamic programming. Now, what do I mean by feel comfortable or feel uncomfortable? These are the sequential problems you find in Stokey, Lucas, Prescott. The first one is the finite horizon version. The second one is the infinite horizon version. Basically, given the initial state k0, you maximize the sum of f functions called period return function by choosing a sequence of k's. But every period you have constraint gamma. The associated problem is this functional equation. Okay, so the solution to this sequential problem must satisfy this functional equation. This is the infinite horizon version of the sequential problem, in which you have to choose an infinite sequence of k's. The associated functional equation has this form. So if you are okay with these functional equations, if you think this functional equation is pretty intuitive, then this lecture is not for you. You wouldn't even see the point of this lecture because the goal is just this. I think the whole thing will take only 30 minutes, and at the very end, this is the equation you will see. Nothing deep. Okay? Then let's begin.